Welcome back, champions. In this module, we are starting with the problems based on types of discontinuity. What does a problem say? You need to discuss the continuity and either it is a removable or not, you have to find. In case if it is a removable, you have to remove the discontinuity. Now, as we can see, here we have to discuss the continuity of f of x at which point x equal to 0. So, f of x will be continuous at x equal to 0 if and only if x is tending towards 0 should be equal to as f of x at x equal to 0. But for f of x at x equal to 0, we already have which value? Which is already in the question, it is 2. Absolutely fine. But for f of x where x is tending towards 0, the equation is from the question, it is sine of x square minus x upon x. So from this equation, taking x common in the numerator, equation would be sine of x into x minus 1 upon x. Students, as soon as you see this equation, what did you recollect? Something is incomplete. What is that? Balancing coefficient. So for balancing the coefficient of x, multiply numerator and denominator by x minus 1. So your equation would be sine of x into x minus 1, the whole upon x into x minus 1 into x minus 1. As soon as you see this, what do you remember? Sine x upon x is 1. So value becomes 1 into 0 minus 1 and your answer would be minus 1. But you remember something. The both values, that is here in this case, the f of x is discontinuous at x equal to 0 as limit x is tending towards 0 is not equal to f of x. So in this case, what to do? It can be made continuous. How? By redefining the function as f of x would be limit x is tending towards 0 sine of x square minus x upon x for x is not equal to 0. This part remains as it is, but the value would change towards minus 1. Note this point here. Here we have changed the value of a function at x equal to 0 and hence it is called as redefining the function. Moving ahead with the next problem. What does it say? You need to discuss the continuity of a function, which of this function has a removable discontinuity, and redefine the function so as to remove that discontinuity. Absolutely fine, my dear students. In this case, we have to define a function f of x such that it becomes continuous at which point? X equal to 0. So, f of x will be continuous at x equal to 0 if and only if you already know this equation. Come on, pick it up. What is it? Limit x is tending towards 0, f of x is equal to f of x at which point? X equal to 0. But from the question, you need what? Limit f of x is tending towards 0. The value is 8 raised to x minus 1 the whole square upon sine x into log of 1 plus x by 4. Students, as soon as you see this equation, what do you recollect exactly? The numerator is in square. Denominator has the two multiple of x. So what to do in this case? The divide numerator and denominator by x square. So what your equation would be? 8 raised to x minus 1 the whole square upon x square. The whole upon sine x into log of 1 plus x by 4 upon x square. In this case, that x square is getting splitted with sine x upon x and 1 plus x by 4 upon x. You remember this standard formula already? What is it? A raised to x minus 1 upon x is given by log a. Therefore, the value would be log 8 the whole square. Absolutely fine. You also know something that limit x is tending towards 0. Sin x by x is 1. So in this case, it would be 1. But did you observe something in that third term of log? What is that? You will have to balance coefficient. So for that, what to do? Multiply and divide by 1 by 4. So equation would be 1 by 4 into log of 1 plus x by 4 the whole upon x by 4. So now I can compare it with the standard formula? Yes. So we also know that limit x is tending towards 0. 1 plus x by x is nothing but 1. So in this case, what would the equation be? 4 into log 8 the whole square. So I can say that limit x is tending towards 0 should be equal to f of x at x equal to z, at which point 4 into log 8 the whole square. Students, such type of problems are expected into the examinations. So keep solving and rise and shine. Thank you.